Hi everyone, welcome to the micro learning session on IoT and its applications. Today we are going to learn about the IoT design and methodology from Unit 4 IoT platform design methodology. In this session we are going to learn about the IoT design methodology. And also we will see why we need a systematic method to design the IoT system and how each step works and how this structure helps us to create efficient and real-time connected applications. Now we will see the IoT design methodology overview. So before going to see the overall design methodology, we are supposed to know what is the IoT. So IoT is a network of physical objects. So in the meaning of the physical object means the things are sensor, actuators, those are the physical objects. So those are connected on the internet. What is the purpose of the connected on the internet means to collect, share and act on the data. So designing the IoT system is not like a building a single app or circuit. So each part is made by the different vendors. Yes, we all know if it is the sensor means, so there are the different types of sensor. So each sensor is developed made by the different vendors, and each sensor uses the different protocols. So making all this communicate smoothly is a difficult process. So the IoT system is a combination of devices, networks, data and the applications, so that only the designing the IoT system is complex due to the varied components and protocols. So a generic design methodology helps ensure the reduced design and testing time, and it will give the easier maintenance, and it has a high interoperability, and it lower the complexity. The IoT design process involves the multiple structured steps to define, model and implement the efficient IoT systems. So the below given diagram summarize the entire design methodology. Here we will see the overall IoT system design methodology. Here the number one is the purpose and requirements. So in this stage it will define what is the purpose and requirements of the IoT system. In the second stage it will give the what is the process model specification, what are the use case, everything it define in the process model specification. And in the domain model specification it will give the what are the physical entities, what are the virtual entities and what are the devices are used in the IoT design methodology, and what are the resources and services in the IoT system. In the fourth step is the information model specification. In that information model specification it defines the structure. For example, it will give the relations and attributes between the entities of all the information in the IoT system. And the next step is service specification. It maps the process and information model to service and define the service specification. And next one is the IoT level specification. It will define the all over the IoT level for the system. And next one is the functional view specification. It will map the IoT level to functional groups. And next step is the operational view specification. It will in the step it will define the communication options and the service hosting options, storage options and device options. And the next step is the device component integration. Here we will see the integrated devices. develop and integrate the components, and finally we are going to see the application development, how this applications can be developed. So the first step is purpose and requirements. So why this can be a first step means, so before designing or coding, you must know what is the problem. For example, we will think, yeah, smart irrigation systems. So if it is a smart irrigation means, what the purpose will be, we need to reduce the water waste. So and then, so based on the problem statement, we have to think over what are the requirements. So if it is the smart irrigation means, we need a sensor, water pump and controller, Wi-Fi, mobile app. So before implementing the any method, we supposed to do the first step is, we have to find out the problem, that is called as the purpose. And for the problem, to solve the problem, what are the requirement is, that is called as purpose and requirements. So here we will define what the IoT system will achieve. We have to define what IoT system we are going to uh, design. That means, yeah, if it is a smart automation or irrigation systems, so like that we have to define what IoT system we are going to design, and identify the problems and goals clearly. So what is the problems we are facing? So for the problems, we have to identify the goals very clearly and specify the functional and non-functional requirements. So based on the goals, we have to specify all the requirements, and also we have to consider the environmental and operational constraints, that is the power, cost, network. So everything we have to design at the first step of creating a design. Here we are taking the example as the smart irrigation system. It aims to optimize the water used based on the soil moisture. And the second step is the process model specifications. So why this can be a second step means, once the goals are known, we need to map the process that achieve these goals. So here we need to give the clear picture of the data flow and system behavior before the implementation of the IoT system. So here we need to define the use cases, what are the workflows, and we have to describe how the user interact with the system, and we have to map the input output behavior of the devices and focus on the sequence of operations and data flows. For example, if the soil moisture is less than 30%, it means we have to send the alert to turn on a pump, and this can be stored on the log data. Log data notify the user. And then next one is the third step is domain model specifications. Now we understood the what is the process. We have taken the smart irrigation system. Here we define the problems, and also we define the what are the requirements, what are the sensors we need, everything we define in the previous step. And we also understood the what is the process. We have to find out the moisture of the soil. If the soil moisture is less than 30% means, we have to send the data to the turn on a pump, and this data can be updated on the cloud and it will notify the user. So after that we have to understand the domain model specifications. So we must identify which components perform the each task. It defines the ecosystems, so who interact with the whom. It identifies the in domain model, it identifies the physical entities, that are the sensor, actuators and devices, and also it identifies the virtual entities. The virtual entities are dashboards, cloud services in the applications. It defines the resources in interaction between them. It also helps us visualize the systems, ecosystems, and by getting the sensor data, the controllers works, and the controller send to the data to the cloud. After that, the user, through the user interface, the user can interact with the applications. In next slide, we are going to see the information model specifications. Once devices are chosen, we must define how they share the informations. It ensures the consistent interpretable data exchange between the device and cloud. So information model specification defines the data structures and attributes, and it identifies the how information will be stored and processed. For examples, the attributes are device ID, timestamp, sensor value, locations. So it ensures the consistency of the data across the systems. In next slide, we gone through the what are the service specifications. So after defining the data and devices, now we assign the responsibilities to the each module. Who does what? For example, in temperature service, it reads the sensor. In alert service, it sends the notification. In the storage service, it stores in the cloud. So what is the purpose of the service specification means? It is split the system into independent and reusable service, that is the modular designs. Now we'll see the what is the definition of the service specification means. It maps the process and information models into the service, and also it defines the communication interface. It identifies which service will run on device, gateway or cloud. So here the example is already we have seen the temperature service, alert service, data storage service. In next slide, we will see the IoT level functional view specification. It defines the level of intelligence and communication patterns of the systems. So there are the usually 5 IoT levels, from the simple device to complex cloud analytics plus automations. So why this step has come as the sixth step means, once the service are clear, you decide how the system is communicated, whether it can be communicates the local means, that is the device to device, or cloud based, we have to decide. And what is the purpose means, it select the appropriate design depending on the system scale and intelligence. For example, here the level 2 is the device sends the data to cloud. If it is the level 5 means system uses the AI for auto decision making. In next slide, we will see the operational view and device integrations. So this groups all the system functions into blocks like sensing, communication, data processing and application logic. Here what is the purpose means, in this step we are visualize the architecture layer by layer. So why it has come as the after the IoT level specifications means, after defining the IoT level, we have to organize the internal functions into blocks for a clear understanding. For example, a sensor sends the data to the gateway. The gateway sends the data to the cloud analytics. From the cloud, the data can be shared in the mobile app. So that is called as operational view and device integration. Here we have to choose the what is the communication, whether it is the Wi-Fi or Zigbee or MQTT or Bluetooth. That means the If it is the device to device communication means we can choose the Bluetooth. If it is the next level means we can choose the Wi-Fi. If it is the next level highest level means we can choose the MQTT. We have to define the storage, whether the storage can be a cloud or local. And the next one is we have to choose the platforms, whether it is the ESP8266 or Raspberry Pi or Arduino, because so based on this only the data can be controlled and handled. And device integration, we have to develop the firmware and test the device interoperability. In next slide we will see the applications development. In this step, developing an application, here the example is a mobile app display a real-time water usage and alerts the users. So, in this step, we are developing the user-facing application for monitoring and control. So, in this application, we are creating the dashboards and analytic panels and mobile or web apps. And also, we are also conduct the testing and optimization, and we will check the security and scalability. In next slide we will see the overall methodology ensures the reduced design and testing time, and it will give the better modularity and interoperability and easier maintenance and scalability. This can be applicable for any IoT domain like healthcare, agriculture, smartphone, industry, anywhere we can apply this IoT. And thank you. I hope you all understood about the IoT design methodology.